I set up the machines one more time for an honorable mention, and I will explain why. Since quality factor is a function of frequency, it occurred to me that I could simply lower the frequency going through the coil and therefore lower the quality. And we could get, in experimenting, end up with a quality that's actually readable on the dial. So I've actually played with some stuff till I came up with some numbers, and now I'll replicate those events on both machines. But the first thing I'm going to do is obviously use the 1 kilohertz. So I'm going to use the same test procedures that I used before. And this is one of the coils that I've used in previous videos that was done with a crystal radio. And it measures 210 microhenries as displayed here. And this has a, using our paper diagram, a quality factor of 1.1 on the IB-2A. At 5,000, obviously, we see the value for the coil remains the same. However, we see that the Q has changed to what I will call just under 25. So we'll call that 24 or just under 25 for the purpose of this demonstration. So that's the value that I got, and recording those two values, we'll now move to the other machine, the 1650, and see what that says for this coil. So let's move on to the other machine. This coil measures 205 microhenries, slightly off on this machine compared to the other. That might have to do with the fact that the coil is nothing more than wire wound, a cardboard toilet paper roll. One sitting on this type of metal chassis and the other one sitting on that metal chassis. Who knows? Whatever. For 5 microhenries, I'm not really concerned. Anyway, Q is 1.1, so the quality factor is the same for both at 1,000. I've connected my external generator, and now we will test at 5,000. In setting up the oscillator here, having changed nothing on this side, we find that using this one, the high Q, that as I turn it, we hit our null at 26. This is 20, 22, 24, and 26 is the null. Anything after that will start to increase. So, not bad. I mean, I'm comparing it to this. This one is like 24, but look at the knob we're working with. That's amazing that they actually came out so close. So we were actually able to see definitively that these are actually quite aligned, in fact. So I think this extra test that I did actually does demonstrate that with regard to values that are greater than 10 and less than 1,000, and somewhere between 0 and infinity, the Q knob is fairly accurate on this IB-2A. We can see that as we read just under 25. This one, looking at the hash marks here, where we still have some resolution, we ended up with 22, 24, just under 26 is in and around just over 25. So outstanding. So I'm glad I was able to get that last test in. I realized it wasn't part of the IB-2A versus 1650 test, but I still thought it was necessary because it did demonstrate the DQ knobs and the fact that they can be tested between both of them if we're simply willing to drop the frequency that we're using to test the coils, and therefore lower our Q value to a point where we can use a value that's actually readable on these dials. Thanks for watching.